सर हाँ सर లాస్ట్ టైం మీకు పంపించారు కదా
లాస్ట్ టైం ఇచ్చిన కదా సార్ ఇప్పుడు ఎంబీఏ సెకండ్ సెమిస్టర్ కదా సార్
అవునవును
సార్ సార్ ఓకే సార్ అదే నేను స్టూడెంట్స్ కూడా పెట్టా సేమ్ లింక్
ఓకే
మళ్ళీ ఏమన్నా
ఓకే Yeah, good afternoon. Am I audible to you?
Yes, sir.
Okay, thank you. The thing is, we were discussing in the previous session regarding the standard deviation, I think so. Anybody having an idea about that, then we'll go further. We discussed about the range, standard deviation, and in the standard deviation, we need to discuss about the coefficient of variance. That is very, very important. This is normally a standard deviation with the step deviation method, what we can learn. The subject is statistics, quantitative techniques actually. Quantitative technique for decision making. Right. Apart from this standard deviation, we need to discuss about the coefficient of variance. What I mean to say, this is the coefficient of variance we can see. Can you able to see this one? Coefficient of variance, variation. This is nothing but the coefficient of standard deviation only. We'll call it as a coefficient of variance, variation, because it gives us the differences between the two products, the consistency between the two products. You can see here as the corresponding relative measure is known as a coefficient of variation. This measure developed by Carl Pearson is the most commonly used measure of relative variation. That is the variation between two things. It is used in such problems where we want to compare the variability of two or more than two series. So two or more than two products, you want to find out the consistency, then this can be applied. Here the coefficient of variation is greater, is said to be a more variable or less consistent or less uniform, less stable or less homogeneous. On the other hand, the series for which the coefficient of variation is less is said to be the less variable or more consistent. So more uniform, more stable or more homogeneous. It means whenever you are finding out the coefficient of variation, which is denoted by CV, the CV is calculated by means of the standard deviation divided by mean into 100. Standard deviation by mean into 100 is the formula where we need to calculate mean as well as standard deviation of each series. When we are comparing the two series, then we can see that whether series A is better or series B is better. You can see here the example 1, illustration 8.13, which is there in your material also. The following data given below state the series is more consistent. Which series is more consistent? That means series A and series B is given. Like an example, if we'll take two companies refrigerator we want to compare, which gives you the more life and which gives you the less life. Like series A, we'll assume it as LG, another one is Samsung. Series B as a Samsung. If we have taken an example, the class interval, which is nothing but age of the refrigerator as 10 to 20, 20 to 30, like that. If you assume in that format, and the series is nothing but the frequency, the number of refrigerators, which gives you the life in between these. If we'll take example in that format, the first will take a series A data with the same classes. We'll find out the mean and the standard deviation. You can see here the mean and standard deviation calculation for both the things. We'll be finding out the mid value is the first thing when the class interval is given. the middle value of this class, 10 plus 20 divided by 2, will be getting an 15 as middle value, as mid value as an x. So 15, 25, 35, 45, 55, 65 are the middle values of these class interval, which is assumed to be an x. Then from this, we need to find out the mean, means frequency is multiplied with x. This is f. The series A is given in the format 10, 8, 22, 20, 12, 18 is considered as f frequency. F into x, the summation of that is 3850, 3850. So this 3850 divided by the total frequency, you will be getting an average, that is but nothing but a mean. Then to find out further for standard deviation, we'll go with the step deviation method, that is D1. D1, nothing but x minus a divided by c. What is x? X is nothing but these mid values. A is nothing but an assumed mean. Among these x only, we need to assume something as a mean. So middle as 35 is assumed as a mean here. When we assume 35 as a assumed mean, then the difference between x and the assumed mean. So 15 minus 35. 15 minus 35 comes to 20 divided by c. What is c? C is nothing but the class interval difference. Difference of class interval is how much? 10 to 20 means 10 is the difference. So that 20 divided by 10, you are getting as minus 2, because x is less and a assumed mean is more. 15 minus 35 is minus 20 divided by 10 is minus 2, minus 1, minus, when we come to the exactly 30, 35 minus 35 is 0, then plus 1, plus 2, plus 3. So most of the time what happens, this will be in the form of ones and twos only, because we reduce the total observations in the form of the 1, 2, 3s only by dividing it with the C, that is class interval difference. Then we'll be getting as a D1. This is multiplied with the frequency F. Here it must be an F into D1, that is FD1. F into D1 square. That means this FD1 is multiplied again with the D1, you'll be getting FD1 square. That is 20 into 2 is nothing but 40. 8 into 1 is 0, 8. 0 into 0, 20 into 1, 24 into 2, 54 into 3. So that is FD1 square. That summation and FD1 summation and F value. That is total of frequency that we require to find out the standard deviation. The formula you can see. So under root of sigma FD1 square by sigma F minus sigma FD1 by sigma F whole square into I. I is nothing but here C only, the class interval difference here consider. The same 10 is to be assumed here. So when we calculate by substituting these values, sigma, that is summation of FD1 square is 278 divided by F is 90. 278 divided by 90 minus sigma FD1 is nothing but 70 divided by 90 whole square. So if you divide, whatever the value you'll be getting, that is squared, then the difference of these two things and square root of that into 10, you are getting as 15.7 as a standard deviation. So the standard deviation is 15.7 and the mean is 42.8. Then you can calculate CV, coefficient of variance, as standard deviation by mean into 100. So standard deviation is 15.7 divided by mean is 42.8 into 100. You're getting CV is 36.77%. So coefficient of variance for the series A is 36.77. Same like that, series B is to be considered and finding out the CV again for the B series. If you find out the B series coefficient of variance, you can check here after calculating standard deviation and the mean and calculating of CV 37.8. So it is B series is 37.8, A series is 36.77. Whenever you are concluding this one, which one gives you the more consistency? More consistency is whichever the CV is less. Just remember, This may appear for 10 marks question also sometimes. So most of the time they'll be asking you to find out which is more consistent. They won't be asking you about coefficient of variance to calculate. Yes, am I audible to you?
Yes, sir, audible. Now audible.
Right. Just now we discussed about the coefficient of variance. Do you find that one? Did you get it? Up to this, we discussed about the series A and B. Is that clear?
Yes.
Right. Then we'll go for the part of skewness. This is also very, very important topic. The skewness is nothing but the data, whatever we collected and we kept it for the observation purpose, whether it is symmetrical or not, we can find out only by means of the skewness. The word skewness refers to the lack of symmetry. That means what? The data is not similar. They are not symmetry. The lack of symmetry is nothing but asymmetrical distribution is called skew distribution. If the value of mean, median, mode are equal, then it is called as symmetrical distribution. That is actually the point. But if the values of mean, median, mode are not equal, then it is called asymmetrical distribution. As per the Proton and Gordon, when a series is not symmetrical, it is skewed. So how much it is skewed, whether it is positive skewed or negative skewed, that can be find out by means of this. You can see here the below observation or below the figure given to you. Everything is there in your material once you go through it. Okay. So here in the words of Simpson and Kappa, measures of skewness tells us the direction and extension of skewness. In symmetrical distribution, the arithmetic mean, median, mode are identical, where this is the thing where you can see middle figure, middle graph, middle image. You can see in this image, the middle point is your symmetrical distribution. The more the mean moves away from mode, the larger the asymmetry or skewed. So here you can see the negative skewed. That means the mean is less, median is more, and mode is more than that. Then it is a negative skew. Whenever you are getting at a positive value of the skewness, then we can see mode is greater, median is in the positive direction, and the mean is also in the positive direction. That means mean is more than the mode. So this is with the test of skewness. You can see if the value of mean, median, mode are not equal, it is skewed, and distribution is skewed when some of the positive deviations from the median are not equal to the sum of the negative deviations. So in a skewed distribution, quartiles are not equidistant from the median. When the data are plotted on a graph paper, they do not give the normal bell-shaped curve. So in a skewed distribution, frequency are not equally distributed at points of equal deviation from the mode. What does it mean? It gives you the clear picture that whenever the data is not symmetrical, then we can see we'll be getting a unbell-shaped structure. It won't be the bell-shaped structure. It may be a negative skewness or positive skewness. You can check the graphs which is shown on the above. When both all the mean median mode are equal, then we can clearly get the bell-shaped structures here, where it is in the middle, so which gives you the normal curve, and which is a tails, having other tails on both sides. So the measures of skewness. So there are the two. There are two persons which has given to calculate the skewness. The three are there, but the most popularly known are two. That is Carl Pearson's coefficient of skewness, which is also known as mean skewness based on mean. Whereas Bowley's coefficient of skewness, it is based on the quartiles and the median. So which is denoted as SKP and SKP. P stands for the Pearson's, B stands for the Bowley's. Where Kelly's coefficient of skewness is based on deciles and percentiles. And most of them, they won't think that this measured with the Kelly's method, they won't be getting an accurate one. So what the people will refer us, Carl Pearson's is one, another one is the Bowley's. Based on the moments also there as skewness, but most of them will prefer either mean or a median. So mean is preferable because it is mathematical accuracy part. Arithmetic mean is applied in this one. Whereas Bowley's only quartiles and the medians. So to find out it, the formula is given clearly here as SKP is what?